This is the Earth Science Classroom. Welcome. This is the Rock Cycle Part 1 video. This is in the Geology Rocks playlist. This video is kind of the complete guide to the rock cycle. Broken it down into different parts as it would be too long of a video to combine. And the way to introduce the rock cycle, the way to teach it, the way to look at the connections between the three main types of rock, and of course the origin of the rock cycle, which I call always the magma and lava, and look at to explain the transitions, the phase changes, the processes that are associated with each part of the rock cycle, and also where they occur. So this video is going to cover the three main types of rocks: the igneous, metamorphic, and sedimentary. It's going to cover the sequence or the processes that are involved with the rock cycle and the movement of material around the cycle. I'm going to look at going to summarize and define and describe the processes and the terms, and look at the outcomes. So these processes create these different rocks in these different environments and situations and locations on the planet. And as you can see, just from these images, you've got these beautiful array and variety of rocks that we find on this planet. There's a massive rock that we live on, but the crust has beautiful examples and different rocks and formations and bedding that we all appreciate and look at in national parks, areas of natural beauty and scenery. We've got Giant's Causeway here in this top middle picture. We got a nice erupting volcano with very low viscosity lava coming out. This is Hawaiian, so Hawaiian type eruption. You've got this beautiful quartz crystal here, which is kind of the foundation of not only the Bowen's reaction series, but also minerals and what's in the crust, the silica and oxygen. We've got this beautiful basaltic columns here in Iceland, which are formed through volcanic activity and cooling, and also one of the mittens, the buttes in Monument Valley and the border of Utah and Arizona in the U.S. So as a basic diagram or image, so you can just go on Google, any kind of textbook you get, the rock cycle is presented in a very simplistic way. Now, from grades 3 to 5, through middle school, high school, through primary and secondary school in Europe and Australia, you get this presentation of a simplistic rock cycle. And you may have different rocks in different positions within the cycle, within the diagram, but it all basically connects, and there's this cyclic nature to the rocks. Now, the average residence time that each rock may spend as a certain type is roughly 20 million years. So the temporal aspect of the rock cycle isn't like, oh, well, this rock's going to turn into a different rock in a week. This takes millions of years to go through the system, which again can be a little bit daunting for students to appreciate that kind of time scale. So the rock cycle contain three rocks, or rock types. You have igneous rock, you have sedimentary rock, and you have metamorphic rock. Now, the other empty box here would be magma, okay, or lava. So that's how I present it. That's the basics. And these red arrows that connect each rock and type is going to be a process. A process that can be either simplistic or very detailed, or in different steps, or in different stages. And it is reliant on what rock it's going from and what rock it's going to, and the location is very important, which will dictate the process, dictate how fast this works, and dictate if there's any steps involved to create the next part of the cycle. Now, the next thing to discuss is that it's always just presented to students as a complete system that really just involves what's written on the diagram. And the interactions are basically endless. You have the interactions with the spheres. You have the chemical and nutrient cycling. Just erase that for a second. There we go. The nutrient cycles. You've got also, you can add in the water cycle. So all these major processes and cycles that interact around and with the rock cycle can be expressed and brought in various stages. Also the locations are very important. Geographic locations of areas where you'll find magma and lava, why they're there and why not other places. The locations of metamorphic rock versus sedimentary rock, and the environments of creating these rocks, depositional environments as well for sedimentary rocks, and locations of igneous and the starting point for igneous rocks. And also you can bring in the different types of each rock. You can bring in a little bit of the how to ID them, the basic classifications of each rock as well. So this rock cycle can start very basically, very simple or simplistic, but you can develop and grow the rock cycle into a very large, complex and holistic cycle that includes many other areas of earth science, geomorphology, and spheres as well. And one last thing to add on the applications is a big one, which is also not always included: the geologic history. So the understanding of the rock cycle and how these rocks are formed and the processes that go into forming these rocks have enabled geologists and scientists to understand the history of the Earth dating back 4.6 billion years and use these rock beddings, these rock strata, these rock formations to kind of like decode the past environments. We can use these to decode fossilized records going back billions of years. We can use this to look at the origins of life from the oceans, the origins of the atmosphere and the composition of gases, and even the step-by-step changes that occurred through certain areas due to the rocks and how they formed, and the index fossils that are contained mostly in the sedimentary rocks. So this is a huge topic that can be very easily linked in to the rock cycle. So as a review, the rock cycle can basically start simplistic, start very easy, and you can discuss that with younger grades and younger kids and students who have very little experience with rocks or any kind of geology background, and you can develop that complexity. You can add more and more details to each part of the rock cycle to add both the scientific complexity and scientific terms to the rock cycle. Then you can link it into multiple topics, subjects, and details into the cycle, so you can develop this large holistic view on the cycle, not just on the basic 3 rocks and magma, but also in the very detailed processes that go into each rock formation. And then you can look at the starting point, which is, for me personally as a teacher, I always like to go into magma and lava as a starting point, because then you can build in the minerals, the composition, the melt, the origin of magma, the temperature, pressure, environmental factors that go into both magma and lava, and the cooling of lava into that igneous rock, that starting rock type. All right, thanks so much, guys.